That's a relief. I thought Tanguy was going to rap again. OK, so library design matters. A good library can delight its users, and a bad one can reduce them to tears. In this talk, I'd like to discuss or revisit an old but gold pattern that you may find useful to make your libraries better. And I'll share with you a few tricks that I've discovered or rediscovered that are useful for this pattern. OK. So it's one of those design patterns. The pattern is called functional options, as the title says. Contrary to what you might have inferred from the concise title, this isn't about functional programming at all. Well, kind of. But yeah, functional options. Functional options is one of those design patterns that you use to help your users create some object. And I'll call this object the product in the rest of my talk. Okay? It's an old pattern. Opaque came up with it in 2014, I believe. And then other people, including Dave Cheney, further riffed on it and improved it. And I don't know about you. I don't know how you feel. But it's quite controversial. That pattern is quite controversial in the Go community. It is the object of both praise and scorn. Okay? And so I needed a motivating example for this talk, and I wasn't too sure which one to pick at first, but I decided to be kind to you and pick a topic that I know you all love. All right, that's the reaction I was expecting, so that's good. So yeah. I honestly cannot think of a topic that has caused as much weeping and gnashing of teeth as CORS has. Okay, this is just a sample of some tweets. I even tried my best to pick tweets that don't contain any expletives, but one of them snuck in anyway. So yeah, people are definitely not in love with CORS. That's an opportunity for the functional pattern, for the functional options pattern. If we can use the functional options pattern to make CORS just a tiny bit easier to work with, then I would count that as a win for the pattern. Okay? So in the remainder of this talk, I will refer to you, member of the audience, as the designers of a fictional CORS middleware library, and we'll name it F-CORS. And yeah. The leading F in the package name can mean whatever you want it to mean. OK. If you don't know anything about CORS, don't worry. You're probably blessed, actually. But all you need to know about CORS is pretty much on this slide and on the next slide. Just be aware that by default, browsers place some restrictions on cross-origin requests. For example, if you've got a script that sends a cross-origin request, such a request will be sent by the browser, no problem. But on the way back, the browser will be like, hold on, it's coming from different web origins, so I'm not going to let this script access the response. Okay? That's in place in browsers by default. And that's where CORS comes in. CORS can actually relax or selectively lift some of those restrictions. And how does that work? Well, the server has to configure CORS and has to add this header to say, browser, please allow carol.com, https carol.com, to read the response. That's CORS in a nutshell. OK? All right. So let's start designing a library that your user will use to produce a CORS middleware. OK? They are going to need some kind of factory function to produce a middleware. And the simplest approach we can follow is just a dumb old function. Positional parameters, just a dumb old function. Okay, but you quickly see that it's not ideal because, well, the only thing it's got going for it is that it's familiar. It's just a dumb old function, but it's not ergonomic. Unless you have the declaration of the function in front of you, good luck trying to remember which parameter or which argument corresponds to which parameter. And actually, there's a more subtle problem, which I'm going to talk about in a minute. It's a problem about expressiveness. The final issue with this, I would say, is that if you want to add a parameter, if you want to add another way of configuring your middleware, you'll have to add a parameter, probably, to the function. And adding a parameter means changing the signature of the function, which means a major version bump, and as Bjorn told us yesterday, that's not something that's something you should avoid if at all possible. All right, so an alternative to the naive approach would be to bundle all those parameters in a configuration struct, and that's what a lot of libraries do. And it does improve things a bit. In particular, it's more extensible because now you're free to add fields to your struct. You're not going to break any existing clients, okay? But I still have issues with this approach. In particular, I find I don't know about you, but the call site, I find the slice literals a bit distracting. I don't know. It's just a personal thing, I guess. And now I can explain what I meant by the expressiveness problem. So you've got a problem when you use this approach, and the zero value of one of the fields is a valid value, okay? It can be used, but it does not correspond to the intended default value. And there's actually a very nice example of this in cores. I don't know how familiar you are with cores. I'm just going to say it, and if you don't understand it, you can forget it immediately. But there's this header called access control max age, and it takes an integer value, okay? Setting this header with a value of 0 tells the browsers not to cache pre-flight responses. But if you omit this header, then the browser will cache responses for 5 seconds. So you see there's a difference between setting the max age to 0 and not setting the max age at all. And with a config struct like this, this distinction cannot be expressed. That's what I meant by the expressiveness problem. So in many situations, you can actually do better by adopting the functional options pattern. With functional options, you've got a factory function, again, but this time it takes a variadic parameter of type option. And for now, don't worry about what option is. We'll talk about this later. And then you've got a bunch of functions. The pattern exports those functions, and they return the various options. And this is what the call site looks like. And I don't know about you, but if you can forgive the repeated mentions of the package names in the qualified identifiers, it almost reads like an embedded DSL. It's pretty nice to read. It's also extensible, same as the config struct, and it's expressive. It actually solves the problem with the 0 value that I just mentioned. The only issue, I guess, that's one of the main objections to this pattern, is that it's unfamiliar. You've got function calls in another function call, and some people don't like that. Some people would go as far as to say that it's clever, and in Go, that's usually not a good sign. But it's up to you to decide. So now that you've had a glimpse of the pattern, I'd like to give you a few tips and tricks to make the best of it, okay? So my first tip is a warning. This talk is not a license to go back to your project and use functional options all over the place. There is a temptation, especially when you come from a language like Python that has keyword arguments, you know, those optional function parameters. You discover this pattern and you're like, great, wherever I need keyword arguments, I'm going to implement this pattern. But slow down, okay? A pattern is contextual, never absolute. You need to think about this. In particular, why should you not use functional options all over the place? Well, it tends to be more expensive, both in terms of time and space. So if you call those functional options on the hot path of your program, that might materialize as a performance bottleneck. But I think the pattern really shines when you have to instantiate or configure complex behavior-driven objects. And I think a HTTP middleware is a perfect example. Okay? All right. Design factory functions as fallible. What's amiss in this signature? The signature doesn't return an error, indicating that whatever happens, we're going to get a functioning middleware. Okay? But then what happens if our users actually mess up the configuration of this middleware? This is not a valid web origin value, and neither is a second one. This one doesn't have a scheme. This one contains a path. These are no valid web origin values. So if you wish to stick to this function signature, you have a few options. You could panic, but well-behaved libraries don't do that in Go. You could return nil, but then you're not giving any explanation as to what happened. You're not telling your users what went wrong. You're just telling them, you're just spitting in their faces, pretty much. And sadly, what a lot of libraries do is that they sweep the problems under the rug, and they just return a dysfunctional middleware. Very sneaky. Because you get the middleware, you apply it, you run your program, and then you realize that it's not working as expected, and it's not clear why. And that's the single most, that's the reason why cores, in my opinion, is frustrating. That's because most libraries do this. They don't validate enough. So in Go, if you've been doing Go for a while, the remedy is simple. Just return an additional result of type error. And then you can inform your users about what went wrong, right? We can actually do better here. Notice that the error message only mentions the first issue. But what if there are multiple issues with the configuration? Well, now in Go 120, we have multi-errors. So you can bundle all those errors into one error value and return all the cause for failure to your users. And that way, they don't have to play a whack-a-gopher game, which is very frustrating. OK. Guarantee insensitivity to option order. With the config struct approach, the Go programming language doesn't care in what order you fill this struct, OK? At least if you use a, what's the name again? A keyed struct literals, that's it. So if you use a config struct, order doesn't matter. But with functional options, order may matter. It depends how you've implemented it. So don't surprise your users in a bad way. Implement the thing in such a way that the order in which options are specified doesn't influence the behavior of that thing that you're trying to build. In our case, the core's middleware. Elucidate the effects of multiple calls of the same functional option. That's another thing that's different from the config struct approach. Okay, with functional options, your users may very well call the same options multiple times, and then it's not clear what happens. Does it mean what does it mean? What do you think it means? Well, it depends on how it's implemented, and this source of confusion is often leveled as an objection against the functional options pattern. So here are two questionable solutions, and then we'll see two more that are more acceptable, in my opinion. You could say, OK, this user has called the same option, the same from origins option twice, so I'm just going to retain the first one and ignore the second one. Or vice versa, you could say, I'm going to ignore the first one and just honor the last one. But if you do that, you're violating the previous principle that says order shouldn't matter. OK? So instead of doing that, we could, in this case, we can totally make the calls additive. OK? Here, in the first snippet, it means that both https://example.com and https://gophercon.eu are actually allowed origins in my course configuration. That's possible. Depending on your problem space, you might be able to implement something like this. Or you can take the easy way out and just say, you called the same option twice, tough luck, here's an error for you. OK? But whatever you choose, whether it's additivity of options or just returning an error, make sure to document it above the option in question, because your users would be scratching their heads otherwise. Strive for immutability. OK, so one of the motivations for creational design patterns is immutability of the product, of that thing that you're trying to build. OK, and immutability, even in Go, is a valuable property, right? Cameron touched upon that yesterday in his talk about dependency management. And here, immutability is a valuable property as well because it's a sufficient condition for concurrency safety. And you do want concurrency safety for a middleware because it's typically invoked concurrently from different Go routines, right? OK. So you should endeavor to make the product effectively immutable. What I mean by that is that your users should not be able to change the behavior of the product once they've built it. Okay? They should not be able to change the behavior of the middleware once they've built it. I don't care how you do it. Use defensive copying if you have to. But it's the best way to do it, I think. Declare a custom option type. Okay. So your factory function could definitely rely on some unnamed function type, as you see in the first snippet. Okay? But I think a better option is actually to declare a custom option type. I'll give you a few seconds. Compare the first, well, the top and the bottom snippet, and tell me which one is more readable. I think most people would agree that it's the bottom one. Okay. And there are benefits to using an option type. Yeah, function signature, readability, that's what I just showed. And another objection that people have against the functional options pattern is that you end up with loads of exported identifiers in the package in question. Some people don't like that. They're like, namespace pollution, get those options out of my site. Okay? But actually, I think the package's documentation is better for it. In general, you want option to rise to the top level of the package. And actually, this is a snippet of a course library that uses the config struct approach. Have a look at the, I don't know if you can read that from afar, but have a look at the documentation. This is the documentation of the different fields of the struct. Harder to read than if you have top-level functions. Okay? All right. Yeah, another issue is that some people say functional options tend to get lost among the other functions, the other top-level functions in the package. So I've added some spurious functions just to give you an example. Right? It's kind of tough to see which are the functional options and which are just regular functions. But again, a custom option type helps here. As soon as you declare a custom option type, all the relevant functional options get listed neatly under the type in the documentation, so they stand out. Okay? Options should operate on an intermediate non-exported struct type. So if you go back to Rob Pike's original posts, functional options actually operate on a parameter that has the same type as the product, the thing that we're trying to build. And they actually also return their inverse, because Rob Pike insisted on being able to reverse the fact of the application of an option. And I get it. Maybe it's useful in some cases, but it actually conflicts with immutability. Here's an example that shows that if you implement it this way, then your users can actually change the behavior of the middleware after the fact. And that's not what we want. So I'm not a big fan of this approach, but to each his own. OK, so a better approach is to operate on an intermediate struct type. And you might be thinking, hold on, we have a config struct again. Where are you leading us? But notice this time, the config struct is not exported. Okay? And there's no reason to. Everything is available through the options that you've already exported. There's no reason to export this config struct. Keep the surface area of your API as small as it can be. John Osterhout would say, deep libraries are better than shallow ones. OK. 3 benefits of an intermediate struct type. Well, because it's non-exported, that means that you're free to make it evolve, maybe to increase performance. This approach promotes immutability, and you can validate all the options once and only once, like this. Okay? You would apply all the options, and then right before returning the middleware, you'd make sure that some options are not conflicting with others, maybe. And then you can actually choose a type other than a struct for your product. Here, I'm not using a struct anymore. I'm actually using a function that takes a handler, and returns a handler. Declare option as an opaque interface. Okay, so your option type could simply be based on some function type as you see above. But I think a better choice is an opaque interface. By opaque interface, I mean an interface that exports no method. Okay? Opaque interfaces in the Go community, not everybody agrees on them. Some people agree that, or some people would argue that interfaces are things that beg to be implemented by users. Okay, but they're actually frequently useful, and I think JBA would agree on that. Okay, so what are the benefits of an opaque interface? Well, as soon as you use an opaque interface, no mention of the unexported config struct type in the documentation. Whenever I see an unexported type in the documentation, I'm like, what is this? Why is it shown to me? I find it distracting. With an opaque interface, you don't have that. And then it also clarifies that users are not meant to extend the set of options. Okay. And if you read, for example, the Uber style guide for Go, they insist that each option should be implemented as a non-exported struct type. So here's an example of how you would produce an option that allows users to configure the max age. And that's a lot of boilerplate. And that's actually another objection, a common objection against the functional options pattern. One reason they do that is they argue structs are actually comparable or can be comparable, whereas functions never are. And they actually want comparability for testability purposes. But I don't think the alleged benefits are justified. Okay, so a simpler approach is just to use a simple function adapter. I don't know if you're familiar with HTTP handler func, but that's pretty much the idea here. And you see that the resulting code is much shorter, not as much boilerplate required. Okay, consider enforcing constraints at compile time thanks to multiple option types. This is exciting. So Joshua Block of Java fame often says, good libraries are not only easy to use, but also hard to misuse. And that last bit is especially important for libraries that are security critical, such as the CORS middleware. Contrary to what you may have heard or read, activating CORS only relaxes restrictions that already exist in the browser. Activating CORS never makes you more secure. Okay? And there's a common misconfiguration, especially when people get frustrated with CORS and there's a deadline. They go on Stack Overflow and people tell them, open everything. Allow access from any origin, anywhere, with credentials, with cookies. And that exposes their users to cross-origin attacks. So we need to prevent such dangerous middleware from being created. And you could just, like the easy way would just be to say, if people try to allow access from anywhere with credentials, we're just going to return an error. But actually, if you study the CORS protocol closely, you'll see that the way anonymous access and credential access work, it's actually pretty different. So maybe you want to reflect that in your library. And there's a way to do that. You're going to scratch the original factory function, and you're going to split it in two different factory functions. Notice that one takes one type, option anon, and the other one, option cred. Okay? And then you're going to split the original option interface into three. One that's only compatible with anonymous access, one that's only compatible with credentialed access, and one that's compatible with both. And once you've done that, it becomes impossible to write. Well, you can write it, but it won't compile. Okay? So that sends a pretty strong message to your users. And actually, they'll be greeted with this compilation error if they try to shoot themselves in the foot. Okay, there is actually a subtlety there. If you use the same concrete type to implement those orthogonal option types, then your users can just use a type assertion or just a conversion, and it'll be able to bypass your compile time constraints, or the constraints that you're trying to enforce. I think I'm running out of time a bit, so I'm just going to zoom through that last one. But if you realize that your package provides a lot of options, and some of them are maybe more dangerous or more advanced than others, maybe you don't want to provide them in one big package. And instead, you can actually split your options into multiple packages. The recipe is that you're going to move all the code into an internal package, and then you're going to use type aliases. You're going to abuse type aliases to export what you need in the original package. And then you're going to move the more advanced or more dangerous options to a risky package. That's the name I've chosen. And going back a bit, yeah, I like this name, risky, because I mean, it doesn't stand out as much as an import of the unsafe package, but it sends a pretty strong signal to reviewers of client code. Something fishy is going on there. Maybe you need some extra time to review what's going on. OK. So that's it. Takeaways. Library design matters. Functional options is a powerful design pattern that can make your libraries better. And further riff on the pattern if you have to. Actually, one more thing. Fcores actually exists. If you need a dependable cores middleware library, check out my library. I'll give you, yeah, whatever. Yeah, actually, perfect, because that gives you more time to scan the QR code. Some references if you would like to dig deeper. And these slides are actually online, so go on.